Hello friends, last class I discussed about the latch. I have already started with the sequential circuit and the latch, right? Working principle of the latch. So you can design the latch circuit by using the two gates. One is the NOR gate, another is the NAND gate, right? So NOR, how the latch is working by using the NOR gate, that I have discussed on last class, right? So today I am going to discuss what is the working principle of the NAND latch gate. Okay, latch means it is used to store the binary information for future purpose, right? So if you try to recall the NOR latch. Okay, uh, so what will happen here? NOR latch means if you want to give the latch means two inputs are there. If you want to give the two inputs at the input side terminal of the NOR latch, so what will happen here? So SR two inputs are there, 0 0 0 1 1 0 1 1. Okay, so Q and the Q prime. If 0 0, no change of memory effect is there. Whatever my previous input, same input will be reflected the present output. Okay, 0 1 means it is a reset condition, 1 0 is set condition, and 1 1 is not used condition. Okay, this I discussed on the NOR latch, right? Now come to the NAND latch. How the NAND? So I discussed the working principle. How we are getting this truth table. Okay. So now I will discuss the NAND latch. So first I'm writing the what is used to happen in the NAND latch. Okay. In the NAND latch, what will happen? So these are my, so SR I am giving two inputs also in the NAND latch. So what will happen here? So if I give 0 0, the not used condition. 0 0 is not used condition for NAND latch. 0 1 is 1 0, 1 0 is 0 1, and 1 1 is no change condition. So just opposite thing of the non-latch. Okay, so how I am getting this output, that I will discuss now. Okay, so in case of the NAND latch, so the structure is like this way. Okay, here I am drawing the structure. Mm, okay, so here is the S, here is the R, Q, and the Q prime. Okay, so this is the NAND latch. Okay, just two NAND gates are there. Feedback connection is there. Okay, so now here I am writing the truth table for NAND gate. Okay, NAND gate, normal truth table. In NAND gate, if you see, two inputs are there. How many combinations? Four combinations you can write. So my output is 1 for first three combinations, and for last combination output is 0. So what is the conclusion we can tell from this truth table? If any input is 0, output is 1, and if both input are 1, output is 0. Okay, if any input is 0, output is 1. So we'll use this concept. Okay, so now so like the NOR gate. Okay, so first I am to give the input in S. Okay, okay, so first I have to give input in S, right? So here my S is equal to 1, here my R is equal to 0. Now considering this NAND gate. Okay, in this NAND gate, so here from the truth table of NAND gate, if any input is 0, my output is 1. Okay, so for this NAND gate, if my R is equal to 0, that means if any input is 0, my output is 1. That means this output is 1. 1 means my Q prime is 1. Okay, now if Q prime is 1, Q prime is entering into this gate. This is also 1, and these two are 1. 1 1 means output is 0. So that means my Q is 0. That means when I am giving S here, when I am to give S here, my Q is 0, Q prime is 1. So if I am giving S is 1 and R is 0, my Q is 0, Q prime is 1. Okay, it is matching with the truth table. Now I will check when memory effect will be there. In this combination 1 1, if I am giving both 1 1, then memory effect will be there. So first I am checking First we will check if I give 0 0 not used, which condition is valid for NAND gate if I am giving 0 0. Okay. So first I am checking if S is equal to 0, R is equal to 0. Okay, so after that I will check this condition, 1 1 condition. So if S is equal to 0, R is equal to 0, that means here this is also 0, this is also 0. Okay, now what will be my Q? Q will be, so be, for that first Q prime is 1, this Q prime is entering here, 1 and 0. 1 and 0 output is 1. Okay, so this is my previous Q and Q prime. Okay, this is my previous Q and Q prime. When I remove S 1 from the S, so that means if S is equal to 0, the previous Q is entering here, right? So 0 into 1 NAND operation means 1, Q is 1. Okay, now come to the Q prime. Okay, Q is 1, this 1 is entering here and along with the R is equal to 0. Again 1 0 is 1, my Q prime is also 1. Now you can see if I remove S, remove 1 from the S, 0 0 condition, both are 1. This is not feasible. Q prime should be the complement of the Q. Okay, so both are 1, that means it is not used condition. Okay, so it is not used condition. Okay, now I have to check this one. So if I am giving 0 1, I will have the 1 and 0. So if I give 1 1, whether same memory effect is there or not, that I will check. No choose condition, right? So I have to check the same memory effect. So directly I come to here, S is equal to 1, R is equal to R. Okay, I am not considering this portion. So first I am giving a logic 1 into S. Now I am giving logic 1 in the R also. In both sides I am giving the logic 1. Okay, so what will happen here? So now here S is 1. Okay, so if S is 1, so both are 1 now. Okay, so if S is 1, my previous Q prime is 1. Okay, Q prime is 1. What will be the Q? My S is 1, my previous Q prime is 1. So 1 1 means Q is 0. Okay, so that means my Q is 0. See, it is matching with this one. Q is 0. Now, your Q is 0, right? The Q is coming here and R is 1. If my 0 1 I am giving into NAND gate, 0 1 I am giving the output is 1. Q prime is 1. That means you can see when I am giving 1 0, my Q is 0, Q prime is 1. When I am giving logic 1 to S and R, so here also I am giving the same, getting the same output, right? Q is 0 and Q prime is 1. That means 1 0 I am giving to reset the output, and the 1 1 I am giving to check the memory effect. Okay. Now, okay, this is the one condition. So this I have checked. Okay, if I give 1 0, this I am getting 0 1, or if I give 1 1, no change condition is there. Now we'll check this one. If I give 0 0, 0 0, this condition also I check, not used. Okay, so I'll check 0 1 combinations. Okay, so it is 0 and it is 1. Okay, first we'll give as 0 1, then I'll give again 1 1. Okay, I will check the whether memory effect is there or not. So if here S is equal to 0, R is equal to 1. Okay, so from the truth table, if any input is 0, output is 1. If S is 0, any input is 0. This I don't know. Okay, if S is equal to 0, if any input is 0, uh, Q will be, now Q will be 1. Okay, if any input is 0, any input is 0 here, any input is 0, any input is this AND gate, output will be 1. Any input is 0 in this AND gate, output will be 1. My Q is 1. Now I am getting Q as a 1. This 1 is entering here. Okay, this 1 is entering here. Now along with the R is also 1. So both inputs are 1 1 means output is 0. My Q prime is 0. Now you can see if I give S as a 0, R as a 1, I am getting for NAND gate is Q is 1 and Q prime is 0. Okay. Now I am giving logic 1 in both input. Okay, I will check memory effect is there now. This I will check now. Okay, if my S is equal to 1. Okay, my S is equal to 1, here also my R is equal to 1. if my S is equal to 1, my previous Q prime is 0. What will be the Q? Here S is 1, my previous Q prime is 0. Okay. So 1 0 means output is 1. My Q is 1. Okay. It retains the same state. Right. Now same Q is entering here. Okay. And R is also 1. So 1 1 means my NAND gate output will be 0 0. Okay. Right. So this S is equal to 1, S is equal to 1, my previous Q prime is 0, it's entering here. 0 1 means NAND gate output is 1, Q is equal to 1. So same Q1 we are getting in both combinations. Now this Q1 Q is equal to 1, that one is entering into this NAND gate. Okay, so here it is 1 and here R is also 1. 1 1 means output will be 0, Q prime is 0. Okay, so that Q prime is 0 here also, Q prime is 0 1. That means in case of the NAND gate, so if I give one input to set or reset the output, so if I give the two inputs, okay, then it will retain the previous state. Okay, it will retain the previous state. Okay, then in NAND NOR gate, NAND latch and NOR latch both are opposite to each other. Okay, so this is about the NAND latch and the NOR latch. Now, so what I am telling, suppose if we give the 0 1, it will be reset and here it will be set. Okay, if I give 1 0 here it is set and here it is reset. If I am giving 1 1, it is not used, here it is memory effect. So suppose if we use any latch, suppose NOR or NAND latch, okay, for reset, for setting or for doing the memory effect we are doing. But sometimes we have to control this latch. Okay, we have to control the outputs. Sometimes it is not required to change the output always. Okay, we have to only we need the memory effect on inside the circuit. So we don't want to, suppose if we are giving the 0 1 1 0, so that time also we don't want to change the outputs from the latch. Okay, so these things can be done by the clock signal. Okay, so suppose you are giving 0 1, okay, but you don't want to change output, it should be as a memory effect. Okay, memory effect should be there for any inputs of the latch, either it is NOR latch or it is NAND latch. So that thing is controlled by the external signal, that is called the clock signal. So from the latch, flip-flop is designed. Flip-flop means it is what is the main difference between latch and the flip-flop. So we are giving the extra clock signal to control the outputs, inputs and outputs. Whether I am giving any inputs to control the outputs, I am giving the clock signal. So that is called the flip-flop. If I connect the clock signal or control signal with the latch, that will become a flip-flop. Okay. When we give the clock signal, the flip-flop will operate as following by the latch, and when we don't give any clock signal, flip-flop will be acted as a memory circuit. Okay, so whatever inputs I am giving, it does not change, it will not change the my previous outputs. Okay, so now come to the so mainly from the NAND flip-flop will designed by from the NAND latch, and NOR flip-flop is designed from the NOR latch. Mainly the NAND flip-flop is famous. Okay, so here I am going to discuss the NAND flip-flop. Okay, so for designing the NAND flip-flop, I have to remember the NAND latch truth table. Okay, so I am writing here NAND latch truth table. Okay, NAND latch truth table. Okay, that's 1 0 1 1. Q prime 0 0 not use condition. Okay, 0 1 1 0 1 0 0 1 1 1 memory effect. Okay, this will required. Okay, when we discuss the NAND flip flop. Okay, so just this portion is related to latch, and you can see this portion is related to latch. Okay, so I have connected two more NAND gates for implementing the clock signal, for activating the clock signal inside the NAND latch. Okay, what I told just now, the clock signal is required to control the entire latch operation. When it's required, we will use the clock. When it is not required, if we want only the memory effect, we will close the clock signal. Okay, so this we will discuss now. If we apply the clock, what will be the truth table? So this entire circuit will become a NAND flip-flop. So truth table will be little bit different from the NAND latch gate, because here I am giving the implementing the clock signal. Okay, right, this is the clock signal. These two extra NAND gates I have connected this portion. This portion you can see, this is related to NAND latch. Okay, now so this S prime and R prime, okay, these two are the inputs of the NAND latch, and S and R, these two are the inputs for mainly NAND flip flop. Okay, now so this is the clock signal. So first my clock signal is 0. Okay, I am giving any input. I don't know, X is anything, R is also anything. X means X may be 0 1 1 0. X, S and R combination will be 0 1 1 0 1 1 0 0. So 4 combination can be possible for S and R. Whatever combinations are there, suppose I am considering my X is, my clock signal is 0. Okay, if I remove the clock signal, whatever inputs I am giving, what will be my output? Okay, this I will check now. Okay, so here my clock signal is 0. Again, you know the NAND truth table of NAND gate. Okay, so if any input is 0, output is 1. Okay, so that means if clock is 0, that means if any input is this NAND gate and this NAND gate is 0, output is 1. Okay, that means S prime and R prime both are 1. So both inputs of the NAND latch, these are 1. Okay, so if both inputs are NAND latch are 1, what is the effect? Memory effect. Memory effect. That means if I remove the clock, whatever inputs I am giving to the NAND flip-flop, it will have the memory effect. Okay, whatever my past values are there, same past value will be written inside the NAND flip-flop. Okay, so now I am giving clock 1. Okay, and I am considering 0 0 combination. 4 combinations I can give for 2 inputs. Okay, so my S is also 0, R is also 0. Okay, so here my clock is 1. Okay, my clock is 1 and this is 0. 1 0 means output is 1. My S prime is 1 also. Here also it is 0. 1 0 means my R prime is also 1 1. Again, if both inputs from for this NAND latch is 1 1 means R 1 1 means memory effect. Again it is memory effect. Okay, now so you see, so clock 0, other combination is giving it memory effect. Okay, clock 1 means if S and N both inputs are 0, then also memory effect. So for NAND latch, if 0 0 it is not used, but for NAND flip flop 0 0 means if clock is activated, then it is memory effect. Again clock is 1, S I am giving 0, R I am giving 1. Okay, so clock is 1 only, S I am giving 0, R I am giving 1 in this case. S clock 1, S 0. What will be the S prime? S prime is 1 only. Okay, here clock is 1, R is also 1. Okay, clock is 1, R is 1. Both are 1. Okay, both are 1 means output is 0. Okay, my R prime is 0. Okay, if S prime is 1, R prime is 0 for NAND latch, S prime, this input is 1 and that input is 0. So it will be 0 1. Okay, my final Q out is 0, Q prime is 1. Okay, so for case of the NAND latch, if 0 1 I am giving, it is 1 0. But for case of the NAND flip flop, if 0 1 I am giving, it is as a 0 1. Okay, now clock is 1 again, S is equal to 1, R is equal to 0. Okay, so again if S is equal to 1, okay, R is again 0. So S1, 1, clock is always 1, 1 1 means my S prime is 0, R prime is 1. Okay, so if this is 0, this is 1 means it is 1 0. Q is 1 and Q prime is 0. Okay, That means when giving 1 0, so I am getting 1 0. For 0 1, that means 0 1. That is called the reset condition. 1 0 I am giving, here it is 1 0. It is set combination. Okay. So last one I am writing here. Okay. Here it is clock is 1, S is equal to 1 and R is equal to 1. Okay. If both are 1 here also it is 1. Both are 1 S prime is 0. Here also both are 1 R prime is 0. Okay. So if these two inputs of NAND latch is are 1, that means it is not used condition. Not used condition. Okay. So now I will again I am repeating clock 0, whatever inputs I am giving here, not memory effect. Clock 1, S and R both are 0 0, it is memory effect. Clock 1, S is 0, R is 1. Okay, S is 0, R is 1, Q will be 0 and Q prime is 1. Clock 1, S is 1, R is 0, Q will be 1, Q prime is 1. Clock 1, if both inputs are 1, then it is not used condition. So I am finalizing the truth table for NAND flip-flop. Okay. What? So this answer is the NAND flip-flop. Okay, so this is NAND flip-flop. So S R Q Q prime 0 0. Sorry. Okay, so clock is also there. Clock 0, whatever inputs I am giving, memory. Okay, clock 1 0 0, memory. Clock 1 0 1, it is 0 1. Clock 1 1 0, it is 1 0. Clock 1 1 1 means not use condition. So this is the final truth table for NAND flip-flop. So there are the 3 more flip-flops that will be extension of this SR NAND flip-flop. Okay, so this is the truth table of SR NAND flip-flop, right? So this you have to remember, this is the truth table for SR NAND flip-flop. So from the truth table I can write the characteristics table, acceleration table and characteristics equation. This I will discuss now. Okay, so this I am removing. Right. So in case of the normal truth table, you can see, so S and R clock is there, S and R also there, and Q and Q prime both outputs are there. But in case of the, I have discussed in the last class also, in case of the characteristics table, you don't have any Q prime. Only the Q is there in the form of the past value and in the form of the present value in case of the characteristics table. Okay, so I am writing the characteristics table of NAND flip-flop. Flip-flop you can write as a FF. So clock is there, S, R and Q and plus 1. I am not writing Q prime here. Any form of the Q prime I am not writing. Okay. So only the Q in the past form and Q in the present form. Okay. So for first phase, clock is 0. Whatever XX is there. Okay. Clock is 0. Then what will happen? Memory effect. Okay. That means whatever you present outputs are past outputs are the same output will be reflect here. Okay, in the present. Okay. So that I am not bothering about this one. Now I am writing the main thing by considering the clock as a 1. Okay. So my clock is 1. I am giving 0 0. Okay. If I am giving 0 0, what is the memory effect in for Q and Q prime? For both cases also memory effect. So here I am only considering the Q, right? So if my past value is 0, present value also will be 0. Okay. Again I am giving 0 0. If my past value is 1, present value is also 1. For 0, memory effect. Memory effect. Same value is reflecting in the present value. Now 1, 0, 1. Okay. 0, 1 means 0, 1 means whatever my past value, my Q will be 0 always. Okay. 0, 1 means my Q will be 0 always. 0, 1 means suppose my past value is also 0, present value is 0. Okay. if my past value is 1, but q is always, present value of q is always 0. Present value of q is always 0. If I am giving 0, 1, it is called the reset. Okay, reset. Okay, whatever my past values are there, it resetting the past values. Okay, 0, 0, right? So now 1. Clock is always 1. 1, 0. 1, 0 means if my past value is also 0, but present value is 1. 1, 0 means always my q will be 1 only. Past value is 1 means present value also will 1. Past value is 0 means 1. Okay. So that is called the set. That means whatever my past values are there, it does not reflecting the past value. Okay. So it sets the present value. Okay. It sets 1, 1 means it sets the value. It will not check the past values. It sets the present values. Okay. If I give 1, 0. Now clock is 1. If I am giving 1, 1. 1, 1 not used. In case of the q and q prime, both cases not used. So 1, 1 means my past value is suppose 0. Okay, it will be not used. Not used means x, forbidden state. Again 1, suppose my past value is 1. Again it is not used, x. Okay, right? For all cases my clock is 1. So whatever my, as whenever I will give the 1, 1, whatever my past values are there, it will be forbidden state, x conditions. Okay. Now, this is the characteristics table. I hope it is clear, characteristics table. So, if 0, 0, whatever my past value, same value is reflecting here. If 0, 1, whatever my past value, it will not check the past value. So, it resets the present values. If I am giving 1, 0, it sets the present values. And if I am giving 1, 1, it forbidden the present values. Okay. This is the characteristics table. If you know the characteristics table, you can draw the characteristics equation. Okay, characteristics equation, that means I will get the relationship between present value and into the past values. Okay, inputs. Okay, present output and input. In case here, this is the output mainly, and that qn is entering into the input. Okay, so qn will be acted as the present value. Input value. Okay, as r and q, 3 are my input in the present state. Okay, so suppose here I am writing S and here I am writing R, Q, N. So by considering S, R, Q, N, how many combinations are there? Total 8 combinations. That's why I am putting the 8 cell. Okay, 0, 1 here, 0, 0, 0, 1, 1, 1, 1, 0. Okay, now here I am checking for 0, 0, 0, 0. Which combination my output is 1 and X? That's I am checking for 0, 0, 1. 0, 0, 1. Output is 1. 0, 1, 1. Then 1, 0, 0 output is 1. 1, 0, 0 output is 1. Then 1, 0, 1 also output is 1. 1, 0, 1 output is 1, and these two cases, my last two cases output is x, x, x. Okay, just I am doing the simple K-map by considering S, R and Qn as inputs, and my Qn plus is the output. So now I have done the K-map, okay, for 3 variable inputs. Okay, right? So now I will get the relationship. So what is my output? Output is qn plus 1. Okay, so I am doing the pairing here. So if I do this pair, this is S. So only S1 is constant here. Now I can do this group. Okay, for this group, this is varying. This I have to consider. That is R prime Qn. Okay. So this simple K-map I am doing. These 3 are inputs and this is the output. Okay. So this is the characteristic. This is called the characteristics table. This is characteristics equation. Okay. Now I will write the excitation table. Okay. Excitation table, that is different from the truth table. Okay, and characteristics table. Excitation table. Okay, so now in case of the truth table also, you have seen that in the left hand side, input side I have written the S and N, and the output side I have written the Q and prime. Okay, but in case of the characteristics table, S and R, these two are inputs only. Okay, in the left hand side I am putting, but in the right hand side I am putting the Q in the form of the past value and the present value. There is no concept of the Q prime. Okay, now again I am come to the excitation table. In case of the excitation table, that is required later. Okay, I will discuss why an excitation table is required. But in case of the excitation table, my Qn and Qn plus 1, there is also no concept of Q prime. Qn and Qn prime, my past output and present output, this will be acted as an input only, and S and R will be acted as the output. That means Qn and Qn plus 1 I'll put in the left hand side, and S and R I'll put in the right hand side. Okay. So this will be Qn and Qn plus 1, these two will be acted as a inputs only. So suppose if I am considering, if these two are inputs, how many combinations I can write? 4 combinations I can write. Okay. So from the characteristics table I can write down the acceleration table, that I am telling now. First I am telling, I told that, so in the acceleration table Q1 and Qn plus, these two will be acted as a inputs that you have to put in the left hand side. Okay, if two inputs are there, how many combinations I can write? 4 combinations I can write. 0 0 0 1 1 0 1 1. Right? So here it is S and R. Okay, so now you can see the truth table. So my Qn and Qn plus 0 0. If this is 0 0, my SNR is 0 0. I will see where any more 0 zeros are there or not. Now you can see here also Qn plus 1 0 0. Here also 0 0, here also 0 0. If it is, so then what is the difference? In this case it is SNR 0 0, but in this case SNR 0 1. That means my S is constant but R is changing in for these two combinations, these same 0 0 combinations. Okay, so here I can, R is change means R is 0 here, R is 1. So that I can write as either it is 0 or it is 1. So that I can write as a X. Okay, so 0 0 means it is 0x. Now come to the 0 1. For 0 1, see only one 0 1 is there here under the Qn and Qn plus 1, you can see. 0 1 means S is 1, R is 0. Now 1 0. So if you see the Qn and Qn plus column 1 0, only 1 1 0 is there. Okay, only 1 1 0 means S is 0, R is 1. Okay, now 1 1. Now you can see in these two columns, 2 times 1 1s are there. Here it is 1 1 and here it is 1 1. Now we'll check the corresponding SR value. So the 1 1 it is 0 0, but in case of this 1 1 it is 1 0. Now in this case my R is constant but S is changed from 0 to 1. So if I combine these two row, okay, so 1 1 means it will be don't care and 0. So S is either 0 or it is 1. So this will call the acceleration table. In acceleration table, Q and Qn plus 1 there should be in the left hand side, and will be acted as inputs, and S and R, these two will be acted as the outputs. So these are about the NAND latch and the NAND flip-flop. So in the next class I will discuss other types of the flip-flop. Thank you, and don't forget to subscribe, like, share my channels.